All right, in this example, we're asked to find an identity for the sine of 2 theta in terms of sine of theta and cosine of theta. All right, now this is actually, you might have noticed I'm covering 9.12 before 9.11. And this is one of the reasons for it, because in 9.11, they give you these double angle formulas, and then they talk about this sum and difference formulas. And again, I like for you to understand where some of these formulas came from. Sometimes like that isn't always possible, but in this case, it's if you know the sum and difference formulas for sine and cosine, you can derive the double angle formula, right? So, and the reason for that is that 2 times theta is just equal to the sine of theta plus theta, right? That is 2 theta, theta plus theta. And so I can just go up to the sum formula for sine and plug it in to the sum formula, right? So this formula right here, I'm just going to use this formula right here for the sum of 2 angles. It just happens to be that the 2 angles are the same angle, right? So I'm going to get sine of theta cosine theta plus cosine theta sine theta when I plug in if theta and phi are the same angle, right? So let me write that down here. So we get the sine of theta times the cosine of theta plus the cosine of theta times the sine of theta, all right? Now notice those 2 terms are really the same thing because multiplication is commutative, right? I can multiply things in any order. 2 times 3 is the same as 3 times 2. 8 times 9 is the same as 9 times 8, right? So multiplication is commutative. So I can rewrite this as the sine of theta cosine of theta plus the sine of theta cosine of theta. Okay, so that's just, I got 2 of the same thing. So that's 2 times the sine of theta cosine of theta. And that's my double angle identity. So the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. Okay, that's what you're going to learn in 9.11 when we get to that, which is coming next. But rather than just throwing a formula at you and saying, here it is, you can see where it came from. You can always derive it. Now, during the non-pandemic school year, you would not be expected to memorize these sum and difference formulas, but you would be expected to know the double angle formulas. So that's why I always like to show this, is because then if you forget the double angle formula, you can always, if you've got access to the sum and difference formulas, you can easily get the double angle identities. All right. Well, I'll meet you in the next video.